Time-programmed ventilation identifies facilities where ventilation control could be optimized. E.g., Ines analyzes whether the facility has ventilation timetables and if the schedules are optimized according to operating times of the facility. Potential saving opportunities are identified based on the building's hourly energy and water consumption. The data is used to deduce ventilation running times and compare them against the actual facility usage times based on water consumption. If water consumption data is not available at an hourly level, default operating times in non-residential buildings from 6 a.m. to 6 p.m. are used. Required input data for the analysis are hourly heat measurement, building type, and area. Hourly water measurement is recommended to make analysis more accurate. The analysis's key findings are summarized at the top of the page and in the table below it. Using the columns menu above the table, you can add or remove information displayed in the table. After the facility names in the second column, you find icons for downloading the facility report, creating actions, and updating analyses. The state column indicates whether the analysis was successful and provides potential reasons for any failure. The status column shows the status of the findings, which you can update using the pen icon. From the date column, you can see when the calculation was last updated. The analysis is calculated for whole months, and as the month changes, you can update the calculation by using the Recalculate button. Actions column shows if an action has already been created from ventilation analysis for the facility under inspection. Subsequent columns display the identified saving potential and results of the analysis. Country-specific average energy prices and emission factors are used in the savings calculations. Next, let's go through the content of the facility report, which you can access by clicking the Download Report button. The report summary presents monthly cost savings for the last year if the schedules had been according to the proposals. The table shows consumption, cost, and CO2 savings for heat and electricity. In the Time Program Detection section, e.g., Ines identifies, based on consumption patterns, when the time programs have been active and when not. Red color indicates time periods when the time programs have not been in use, while green indicates periods when the programs have been active. However, green does not necessarily imply the absence of savings potential in the facility. Gray periods, which are weekends and summer months, have not been analyzed to avoid erroneous results. You can use the mouse scroll wheel to zoom in on the consumption graph for your desired timeframe. The regression analysis compares the building's energy consumption during and outside its operational hours. If the difference between these is not significant enough, there is probably savings potential in ventilation programming. The green line represents the modeled level of energy consumption, which could be achieved outside the operating hours if ventilation usage were optimized. In the Timetable Suggestions section, identified schedules are compared to the facility's actual usage times to analyze whether the schedules align with the operating times. The section presents proposals for the facility's ventilation time programs separately for weekdays, weekends, and public holidays. Optimal ventilation usage is based on the recommendation that ventilation should start 2 hours before the facility's use starts and stop an hour after the usage ends. Usage times are primarily identified from the building's hourly water consumption. The premise is that when there's no water consumption, there are no users in the building. A small continuous water consumption is allowed so that facilities with, for instance, minor water leaks are not automatically excluded from potential saving opportunities.